Let us discuss one more example on inductive proof using principle of mathematical induction. Consider P of n is equal to 7 plus 13 plus 19 plus 6n plus 1 is same as n times 3n plus 4. Call it as equation 1. We have to prove that for any value of n, given statement is true. So first we'll start with the basic step. So we'll consider n is equal to 1 and first term of this series is 7. So left hand side is 7. On right hand side, if we replace n by 1, then that would be 1 into 3 times 1 plus 4, which is 7. As we can see that left hand side is same as right hand side. So P of 1 is true. Step 2 is for induction hypothesis, where we are assume that given statement is true for some n is equal to k. So we can rewrite the equation 1 as P of k is equal to 7 plus 13 plus 19 up to 6k plus 1 is same as k into 3k plus 4. Simply we have to replace n by k in equation number 1. That's it in induction hypothesis, and we are assuming that this is true. So P of k is true. In induction step, we will try to prove our assumption for next value of n. That is, for n is equal to k plus 1, what we need to prove is, so we'll replace n by k plus 1 in equation 1, or we will go up to k plus 1 step in the series. So that would be 7 plus 13 plus 19. Then kth step would be 6k plus 1, and k plus first step would be 6 times k plus 1 plus 1 is equal to, on right hand side of equation 1 we have to replace n by k plus 1. So that would be k plus 1 into 3 times k plus 1 plus 4. Again, there are two approaches. Either we will start with the left hand side of this equation number 3 and we will derive the right hand side of it. Or the another approach is that we will simplify both the sides simultaneously, parallelly, and at some stage we will prove that okay, both of these are same. So somehow we have to show that this equivalence is true, whatever approach we use. So we will be preferring the second one. I'll proceed with both the sides and I'll show that okay, these both are identical. Fine. So in equation 3, whatever part is shown in red color can be replaced by blue color of equation 2 because they are same. We already have assumed that P of k is true. So addition of first k term is same as k into 3k plus 4 from the equation 2. So let us replace it. And on right hand side, we are simply multiplying that 3 within the k plus 1. So we have k plus 1 into 3k plus 7. So that is the simplification of right hand side of the equation 3. Let us multiply k inside into the left hand side. So we will have 3k square plus 4k plus 6k plus 7. Right? And on right hand side, we are multiplying k plus 1 with all the terms of next part of the equation. So that would be 3k square plus 7k plus 3k plus 7. If you look at the carefully on left hand side of this, then that would be 3k square plus 10k plus 7. And on right hand side also we have 3k square plus 10k plus 7. And it proves that left hand side is equal to right hand side, and hence P of k plus 1 is true. So we can make the statement that given P of n is true for any value of n. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel Code Crafts. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.